Alright, silly people, here's the situation. So this is the code that is given in the text. It's an example of the trapezoidal rule integral of the function x to the 4 minus 2x plus 1. It's been in previous videos up to this point. Um, and this time we're going to modify it to calculate a fractional error using an equation in the book, and also compare it to the actual fractional error, um, to compare it to the exact value of 4.4, right? Um, so obviously, if you wanted to calculate the value of the integral that the um, problem is talking about with n equals 20, all you have to do is change the n line and you can get that value. You can see it's already pretty close to 4.4, but to get the calculated fractional error, you need to have two different n values. So I'm just going to create a list for n to run over. It's going to be 10 and 20, right? And then just, that should be for n in, my bad. And then move all those guys forward here. And instead of printing out the values of the integral, let's go ahead and store them in the list, ILS, and then it's going to be empty, and then we're going to ILS.append that stuff there, the result of the trapezoidal rule integral, right? The calculated fractional error is just given by the symbol epsilon2. We haven't really gotten into LaTeX in this series yet, so I'm just going to say E2 instead of epsilon2. That's going to be equal to, it should be the second calculated integral minus the first calculated integral, the way we've set it up, divided by 3, right? But then also, you can just get the fractional error if you do fractional error using the standard formula, which is just going to be your theoretical value minus your measured value, so ILS2, and then divided by the exact value. And so let's give that a run. It should be ILS, not I. I is a different thing from a previous video. And then it's not 2, it's 1. Yeah, my bad. But yeah, so the error supposedly is 0.026, provided the proof that Mark Newman does in the text preceding this problem. But the actual fractional error between the 20 value is given by 0.006. So the difference is that the calculated fractional error is based on relationships between multiple different numerical calculations of the same integral. It's not at all really based on the exact value of the integral, and so the fact that it's not derived from the actual integral at any point means it's going to be slightly different than what the fractional error is, knowing the value of the integral. So they are not going to agree. But I think that's it.